Hey, how's it going? This is Mr. Hernandez, and I'm going to be going over this IXL finding probabilities using two-way frequency tables. So the first thing you're going to want to look for is these conditions here, where in this first problem, the first condition is landing on the rainforest, and in this case, all this is the rainforest. The second case is landing on a tent, and in this case, this is the tent. And then the key word here is the "and," which is right here, the intersection. So the intersection is where you can imagine on a Venn diagram that these two things meet. So in this case, it'll be 2 out of, well, you're going to have to determine the total number. So 1 plus 5, that'll be 6. 2 plus 4, that'll be 6, which gives you a total of 12. You could also determine the total by adding these vertically. 1 plus 2 is 3. 5 plus 4 is 9. When you add those together, you should get 12 as well. Since, these two are well, okay, so that's going to be 12, 2 out of 12. And then you're going to have to reduce that. In this case, we can reduce by 2. So that'll give us, dividing 2 divided by 2 is 1. And then 12 divided by 2 is 6. So that would be 1/6. So I'll type that in here. Let's see. All right, cool. Okay, so I'm going to fast forward a skill. This is pretty much the same thing, so I'm going to pass by one more. Okay, this is a good one. All right, so this is asking for an OR. So whenever you see an OR, you're gonna have to change your strategy a little bit. But let's look at this here. What's the probability that a randomly selected student is irresponsible, which is this, or does not have 0 siblings? So in this case, this is 0 siblings right here, but this would be does not have 0 siblings. And the key word here is OR. Now, OR is something that is important when it comes to probabilities, because if in this case you're talking about OR being mutually exclusive, in this case you could see this is mutually exclusive, and you see the OR, well, then you could just add this first probability and this second probability. That's the addition rule here for when they are mutually exclusive. And that means mutually exclusive means they don't intersect, right? They don't happen at the same time. Now, when they're not mutually exclusive, that just means that you have two events and there is some intersection right in the middle, right? A Venn diagram, there's stuff in the middle. So when they're not mutually exclusive, what you're going to do is you're going to add the total events here, but then you're going to subtract this middle part where they happen at the same time, which is the probability of A and B. So this is the formula that we're going to use, adding up both probabilities and then subtracting where they intersect, subtracting the. Okay, so let's look at the OR. So this here is, well, let's look at this. How many students are irresponsible? Let's see, 5. And this is out of, let's see, well, let's, okay, how many students do not have 0 siblings? That would be here, which is 6. Okay. So that's going to be out of how much? Well, if we add all these up, this is going to be 11 students total. So if we add the probability for this is 5 out of 11. If we add the probability for this is 6 out of 11. But then we're going to have to subtract the probability of A and B. And so where do they intersect? Well, they intersect right here. So that's going to be minus the 2 out of 11. And so here we have 5 plus 6 is 11, minus 2 is 9. So that's 9 out of 11. Now, something that you can consider is each of these numbers here, 3 plus 2 is 5, plus 4 is 9. You can also add those and get 9 out of 11. That's the answer. That's going to go here. So you could either, there's two options. You can add the total number of both of those probabilities, which is what we did here, and add them together and then subtract this intersection. Or you could just add each of these 3 boxes here, and that would also give you the same answer. But I just wanted to make sure I showed this formula here. This is an important formula that exists for events that are not mutually exclusive. So let's put this in here, 9 out of 11. Okay, so here's another. I want to do one more of these. Here prefers e-readers, which is this, and that's a total of 10, right? And then reads about 1 hour per week, and that is this, which adds up to be 12. So here you have the intersection right here is both of those. So we're going to go ahead and use this probability rule where we're going to do the probability of A or B minus the probability of A and B. And actually it's the more precise is for this is for not mutually exclusive, since we see the intersection. Okay, so that's the key word here. When they're not mutually exclusive, you take the probability of A, you add it to the probability of B, and then you subtract the probability of A and B, which is where they intersect. In this case, that would be 6. So the probability of A is, well, I'm just going to look at these here. So what's the probability of preferring e-readers? That's going to be this, which is 10. What's the probability of reading an hour a week? That's going to be 12. And then where they do both? Well, that's going to be here, 6, and highlighted in blue. So 10 plus 12 is 22, minus 6 is, let's see, 12, 10, 9, 8, 7, 6. So that's 16. And then out of the total, which in this case we could add these two, and that's 20. They add up to 20. Or we could add these two here, and then that's 4 plus 4 is 8. 12 plus 8 is also 20. And remember, the other way you could get it is just by adding each of these boxes, right? So that's 6 plus 6 is 12, plus 4 is 16. So those are two ways of doing this, okay? You could either use the formula, which, of course, when you're using this formula, you definitely, this formula requires you to add all of the probabilities and divide it by the total, and then subtract it from this where they intersect. But the nice thing about this using this table is you don't have to use this formula here. You could actually just add up each of these individually, and you should get the same answer. So if we reduce this, this is going to be, let's see, 8 over 10, and then we could divide it by 2 again, and that's going to be 4 over 5. Okay, so again, that's just your two options. If you see the word or, this uses the word and, so you're really just looking for the intersection, not caffeine free. So if this is caffeine free, not caffeine free would be down here, caffeinated, and then this is not mint, so this would be not mint. And since you're seeing the word and, you really are just looking for this point of intersection here. So again, this word and is the point of intersection, so that's just 2 out of, and then you would add up, these two and get 12, these two and get 4, so that's a total of 16. And then you could confirm that by adding these two vertically. 7 plus 2 is 9, 5 plus 2 is 7. That does add up to 16 as well. So this should be 2 out of 16, and then if you reduce it, that should be 1 out of 8. But all right, I hope that helps you. Have a good one.